Welcome to Developer Service YouTube channel. On today's episode, we're going to be showing how we can create a simple programming language in Python, which will include a tokenizer, a parser, and an interpreter. Of course, we are not going to be building a full-fledged programming language like Python itself or JavaScript or anything like that, but we are going to be building a simple programming language that will allow to assign values to variables, perform calculations, and print the output. So when you are building a programming language, there are several steps in programming pipeline that you need to take in consideration. First, you start with the source code. Then you create a tokenizer that takes the source code and parses into tokens. Then you have the parser, and the parser collects the tokens and creates an abstract syntax tree that will allow the interpreter to then generate the program and create the program output. So let's start with the tokenizer. By the way, the source code for all the examples that we'll see here will be in the GitHub repository that I'll share the link in the description. And you can also refer to the blog post in the developer service blog for more information. So what is a tokenizer? Well, a tokenizer breaks the source code, that is plain text, into a sequence of meaningful tokens. So let's take the example of this code, and then the tokenizer will return something like this. So as you can see, it identified the plain text into predefined tokens that can be used later on by the parser to understand what is happening in this particular piece of code. So let's see the code example for the tokenizer. So we start by defining which is the different token types that we're going to support. In this case, the let, print, the number, the different identities, equals, the divides, the times, so all the arithmetic operations. So all of these are the token types that we are going to support. And then we have the function that creates the tokens from the source code. It starts by collecting the size of the code, and then for each of the possible token types that in the patterns that we have predefined, it will try to match to see if any piece of the source code is going to be matching that. Even if it's a match, it will insert that into the list of tokens, and it will return then the full list of tokens after it finalizes. If we run this code to see the example, we have the example of the code let x equals 5 plus 2. So if we run this code, and you see it has generated the corresponding tokens. So the let, the ident, which is the equal, the x, in this case the variable, the equals, then number 5, then the plus, which is the plus sign, and the number 2, and then the semicolon, which also establishes the end of the sentence. So now that we have the tokens, we can start working on the parser. So the parser reads the list of tokens and builds an abstract syntax tree, which is a structured hierarchical representation of the code. So if we go again to the previous example of the let x equals 5 plus 2, then we have the tokens as we've seen before. So the parser will turn into the abstract syntax tree, and inside we're going to be having the let statement, which has a name and it has a particular value. In this case, the value is the result of the binary operation of a number and the operation in the other number. And then, of course, we have the print statement after the let statement that prints the variable x. So that's how an abstract syntax tree looks like. So the parser is the more complicated part of a programming language. That means that it needs to parse all the tokens into meaningful instructions that can be executed later on. And for that, for creating the parser, we're going to be defining several different classes that represents the tokens and the actions of each tokens or the components of each token. So we have a class for number, which of course has a value. We have a class for identifier, which has a name. We have a class for a binary operator, which has the left number, the operation, and the right number. And we have the let statement, which of course also has a name, which is the variable, and the equal, which will be the value that's really assigned to. The print statement, that of course holds the value that's going to be printing. And then we can work on our parser class itself. So initialize our local variables for the class with the tokens in the current position. So the current token just returns the current token, otherwise the end of file, meaning it has finished. We have one method that's called it, which is putting the token into a stack. You can consider that the parser is going to be creating a stack of the different tokens. That's how it creates the tree. We have the parsing itself, which is going to be parsing the different type of arguments. In this case, if it's a let, then it's going to be parsing as a let, which is one of the commands that we're supporting. And if it's a print, it's going to be parsing the print. And now we parse the let. So we parse the let by first, of course, eating or adding to the stack the let command itself, and then the name, which is going to be coming from the token. Then we put the identity, which is the variable. Then we put the equal signs. Then we parse the expression, and this will be the binary operation. And then we put the semicolon into the stack. Then of course we return the let statement. The parse print, similar. It will put the print command to the stack. Then the left parenthesis, the expression, and the right parenthesis, and then the semicolon to signify the end of this command. And then we have the parse expression, which of course is going to be parsing the term, which is the components of the different parts of the operation. So if it's the plus or minus, then we're going to be passing setting that as the binary operation, and we're going to be inserting the left variable, and we're going to be parsing the right one, because it can also be a combination of a set of operations. So we pass the term times and divide, we put the binary operation, and we parse the different types of possible operation division by keeping the standard order. So this is pass term, the pass factor also similar with the different numbers and the identities and left parameters and right parameters if it exists. And now we have our code example. So again, we have the let x equals 5 plus 2, and we're going to be printing it. So first we are going to be creating the tokens using the code example or the function that we defined before. We're going to be creating an instance of our parser class, so that we just define here, and we're going to be calling the parse method, and then we'll have the abstract syntax tree, which is going to be printing. And if we run the code, so you see it has parsed the code for the tokens, and now the abstract syntax tree. So we have the let statement, which has the name x, which is the variable. Binary operation on the left side, it has the number which qualifies. Operation is plus. On the right side, we have the number with values 2, and then the print statement, which will print the name equals x. So the final step is now evaluating the abstract syntax tree, which means running the language itself. So I've built a tokenizer, and I've given a parser that gives the abstract syntax tree. Now we need to execute the tree. And in terms of the basic function of an interpreter, it is the walks the tree, evaluates each node, keeps track of the variables, in this case it's going to be in memory, then it can produce side effects, in this case like printing an output. So let's now see the code for the interpreter. We start by defining a class environment that will be responsible for holding our variables, and we have a set variable that sets the variable value and associated to a particular value, and the get variable that of course returns the value for that variable. Then we define our interpreter itself. We start by creating an instance of the environment, and then evaluating that will pass through the tree and evaluate each of the nodes. And it will do that by checking which type of node it is evaluating. If it is a number, then it just returns the value. If it is an identifier, then it gets the variable from the memory. If it is an instance of binary operation, then it will have the left and right side, which will evaluate depending on the current operation. So it will get the values for the left, the value for the right of the different nodes. And depending on the arithmetic operation, it will perform that operation plus, minus, multiply, and divide. If it is a let statement, then it's just going to be getting the value of that node and then setting that variable into memory. And if it's instead of the print statement, then it's just going to evaluate that node. In this case, the evaluation is printing that value. So if we go back to our previous example, we have now let a equals 10, and then the let b equals a plus 20 times 2, and then we're going to print the b. So again, we're getting our tokens, which will be printing also out to see. We are going to be parsing those tokens into the abstract syntax tree, which will also be printing. We are going to be creating an instance of our interpret, and for each of the nodes in the abstract syntax tree, we're going to be evaluating it in the interpreter. If we run the code, we start by getting our tokens of the different source code expressions. We created our abstract syntax tree. In this case, let a equals the number which has a value 10, and the let b, which is the binary operation resulting from the a variable, and also the plus and the binary operation of 20 in the binary operation of times with the number 2, and then we print the result of that, and the result of evaluating that expression is 50 as it has printed to the output, and as you can confirm on the code. So we have 10. In this case, we multiply 20 times 2, which is 40, plus 10, that will equals 50. So we also keep the standard precedence of the binary operations. And so that's how we can easily build in 1 weekend a programming language. Of course, it's not Python or it's not JavaScript, but I hope this video has allowed you to get an understanding on how programming language works, which starts by the source code. Then we have our different tokens, and then we parse the tokens, and then the interpreter executes the abstract syntax tree, which is the results of the tokens, and that runs the code. Like this video if you like this content, subscribe for more content about Python, Django, and AI, and until next time, happy coding!